this video, we're going to look at some examples of indeterminate quotients and apply L'Hopital's rule. All right, so when we look at this limit, we look first to see what's happening to the top and the bottom. And we always have to check this, because if we don't check it and apply L'Hopital's rule, we may get the wrong answer. So I see that as x goes to 0, x goes to 0. As x goes to 0 on the bottom, we go to 1 minus e to the 0, which is 1. And so 1 minus 1 is 0. So this is an indeterminate quotient, which means L'Hopital's rule applies. And that means this limit is equal to the limit, as x goes to 0, of the derivative of the top, which is 1, over the derivative of the bottom, which is minus e to the x. All right, now I look again. I see the top goes to 1 and the bottom goes to minus 1. And so this quotient goes to minus 1. So this limit equals minus 1. Not so bad. Let's look at another example. Let's look at the limit as x goes to infinity of x cubed over 3 to the x. Well, we know that as x goes to infinity, x cubed also goes to infinity. And we know the graph of 3 to the x looks like that. And as x gets really big, 3 to the x gets really big. So they both go to infinity. So infinity over infinity is an indeterminate quotient. And so L'Hopital's rule applies. So this limit is equal to the limit, as x goes to infinity, of 3x squared over, got to remember the derivative of 3 to the x, and that's ln of 3 times 3 to the x. And I look to see if this has gotten any better, and I see the top goes to infinity and the bottom goes to the natural log of 3 times something going towards infinity, so that just goes towards infinity, and I have an indeterminate quotient again. Now, I get to apply L'Hopital's rule again, because these are two functions who don't know their derivatives of others, and their limit as x goes to infinity is an indeterminate quotient. So L'Hopital's rule applies to this quotient. So I take the derivatives again, and I get the limit as x goes to infinity of 6x over, remember my constant stays with me, and the derivative of 3 to the x is the natural log of 3 times 3 to the x. And so now I look to see if this is better, and I say, the top is going to infinity still, and the bottom is also going to infinity. Am I in trouble? But if I stop and think about it, I realize that here I had x cubed, here I had x squared, and here I had just x. And I bet if I do this one more time, I will be done. Well, let's see. We have an indeterminate quotient here, so L'Hopital's rule applies again, and this is equal to the limit as x goes to infinity of 6 over, well, remember my constants come with me, ln of 3, and then the derivative of 3 to the x is ln of 3 times 3 to the x. This time the top goes to 6, the bottom goes to infinity, and so now I have an answer. The limit as x goes to infinity of x cubed over 3 to the x is 0. All right, let's look at one more example. Now, let's pretend like I get tired of checking. She keeps asking me about indeterminate quotients, so I'm just going to go straight to L'Hopital's rule. So I come down here and I say the limit as x goes to 3 of this quotient is 2x minus 1 over 1. Oops, that didn't look so good. X goes to 3. All right, well now if I plug in, I see the top goes to 6 minus 1, which is 5, over 1, which is 5. Now, just to illustrate a point, I'm going to go back and I'm going to check, okay? So if I plug in 3 to the top, I get 9 minus 3 over 3 minus 2. So this is 9 minus 6, which is 3, over 3 minus 2, which is 1. So this limit actually equals 3. And by the way, that's not 5. So it is very dangerous. Got a little red flag here. It is very dangerous for you to apply L'Hopital's rule to something that's not an indeterminate quotient, because it is not right.